Welcome. This video is going to be broken down into two parts. Actually, let me just take these off. This video is going to be broken down into two parts. The first part is going to be talking about the different parts of a circle. Welcome back. This video is going to be broken down into two parts. The first one is going to be going over the parts of a circle, and then the second one is going to go over the circle formula and the transformations for finding the center of a circle and for finding the radius. Let's talk about that first one. So, for the parts of a circle, the first part is the circumference. The circumference is the outer ring of the circle. It is like the perimeter of the circle. The next thing is the radius. If you have a spot in the center of the circle and you are drawing a line from the center of the circle to the circumference, that is a radius. It is halfway across a circle from the center to the circumference. Nextly, we have the diameter. A diameter is from the circumference of a circle through the center and then all the way out to the other end. The diameter cuts the circle in half. Next, we have a chord. A chord is a line that goes from the circumference to the circumference and does not go through the center of the circle like the diameter does. So a chord cuts a circle into two pieces and it is a line segment. That's the definition of a chord. A chord creates a segment inside. So this is a segment. And a chord also creates an arc. So there's a point, there are 2 points on the circumference where a chord intersects with the circle. And the part of the circumference between those points is called an arc. There are two kinds of arcs. There is a major arc and there is a minor arc. A major arc is more than 180 degrees, and a minor arc is less than 180 degrees. Next, let's talk about some lines that go through the circle and continue on. If you have a line, much like a chord, that goes through the circle and not through the center, this is called a secant. Remember, a chord stops at the circumference, but a secant continues on through the circumference infinitely in both directions. If you have a line that continues on in both directions and intersects the circle at exactly one point, that is called a tangent. Finally, the last part of a circle that I want to talk about is called a sector. If you have two radii, the area that they cut out like a slice of pie, this is called a sector. Let's talk about the formula for a circle. In standard form, the formula for a circle is x minus h squared plus y minus k squared is equal to r squared. This h value is the amount that we are moving the center of the circle to the right. This k value is the amount that we are moving the center of the circle up. If we move the value to the left, that is the opposite of moving to the right, so we would have a negative for our h value here. And subtracting a negative is the same thing as adding, so we would wind up with x plus h if we were moving to the left. Similarly, if we are moving down, we would have a negative for our k value, and subtracting a negative is the same thing as adding a positive, so we would have y plus k if we were moving down. Next, let's take a look at how this would work for writing the formula for a circle, or the equation for a circle. If we have a circle with a center at 2, -8, and it has a radius of 9, what would the formula for the circle look like? Well, we have moved to the right 2, so our h value needs to be 2. So we will have x minus 2 squared plus y minus, our y value has shifted to -8 minus a -8 squared is equal to our radius of 9 squared. So simplifying this out, this will remain the same. X minus 2 squared plus y, and we're subtracting a negative, plus 8 squared is equal to 9 squared is 81. So this would be the equation that describes a circle where the center is at 2, -8, and we have a radius of 9. What if we are given a formula and we're told to find the center and the radius? So let's take a look. If we have x plus 7 squared plus y minus 5 squared is equal to 16. How would we find where the center of the circle is and where or what the radius would be? Well, the radius is very straightforward. The radius would be the square root of our constant on this side. So we would square root the 16 to turn it into 4. And that is the value for our radius. Now, over here, we have x plus 7. This is the same thing as x minus a -7. And remember, in our circle formula, we are subtracting the h value. We are subtracting the amount that the center has moved along the x-axis. Since it has moved -7, the center of our circle will have an x value of -7. On the y side, we have subtracting 5, which means that the y value will be a positive 5 because we subtract the amount that we have moved up or down. So the center of our circle is at -7, 5, and we have a radius of 4. Let's look at when we are given information like the center of the circle is at -4, 8, and we are told that it passes through the point -2, -1. What should we do in this situation? Well, first we can definitely write out our first half of the formula. X minus -4 plus y minus 8, and both of these are squared, is equal to, now we need to find our radius. To find the radius, we need to find the distance from the center to this point on the circumference. To find the distance between 2 points, we need to find the difference between the x values, the difference between the y values, square and add them, and then square root that result. So that is, remember our distance formula, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. It's the Pythagorean theorem, just written very fancy. So let's do -4 minus a -2 is -2. Square that and get 4. 8 minus -1 is going to be 9. Squared is 81. 4 plus 81 is 85. Square rooting that, we have a distance of 85. So that would be our radius. Our radius would be square root of 85. And that value is squared according to our circle formula. So the neat thing is, since we have a square root that is being squared, the root will go away because it will cancel out with the exponent. So we are left with a final formula that looks like this. Oh, and we can change this into plus 4 over here. We can change that to plus 4 because we're subtracting a negative. So we have x plus 4 squared plus y minus 8 squared is equal to 85. Lastly, let's take a look at a problem that has or requires a little bit more of our algebra skills. What is the center? So we're looking for the center and the radius of a circle with the following equation. X plus 5 squared plus y squared minus 6y is equal to -5. This is an interesting one. If we look back at our circle formula written up top, there is no y. There is a y squared because we have the y inside of these parentheses and it's being squared. But what about this random y here? So what are we to do? We need to do something called completing the square. We are going to turn this section here into a perfect square trinomial and then factor it so that we get a binomial that has been squared. To turn this into a perfect square trinomial, we are going to need y squared minus 6y, and then we need half of this squared. So half of 6 squared, so half of 6 is 3, squared is 9. And we need to have an added 9. We can't just manufacture a 9 out of nowhere though. So we need to add a 9 to the constant side as well. Now that we have this trinomial, we can factor it into y minus 3 squared. Now we can rewrite our formula that we're given and substitute this y minus 3 squared where we have the y squared minus y. So let's do that real quick. We'll have y minus 3 squared. Over here on this side, we have a negative 5 plus 9. This is going to equal a positive 4. Finally, now that everything is set in the standard form for a circle formula, we can find the center as being negative 5 for our x value, or for the x value, since we should be subtracting it, and 3 for the y value, and the radius is the square root of our constant. So square root of 4 is 2. So this is our center, and this is our radius. That is all I have for you today. If you found this video to be helpful, consider liking and subscribing. And if you have a topic you would like for me to cover in the future, leave it down in the comments below. As always, have a fantastic day.